Well, industry trends are showing the IP transformation is being very, very effective. It's found to be much more inexpensive to deploy than, say, synchronous digital hierarchy, legacy technology, static and hardwired alternatives. This is an inevitable trend for the industry to transfer to all IP. We're finding that this transformation is occurring in such industries such as Internet of Things, IoT, for appliances, vehicle maintenance, home security, and other areas. So it's really taking off quickly. Well, the solution for IP legacy quality of service, or lack thereof, there's been at least a half dozen fixes to IP introduced over the years. Even just at layer 2 level offering, MAC layer, TOS, DiffServ, RSVP, MPLS protocols, and various RFCs to address the problem. Carriers offer often a mix of protocols to deliver all different types of IP lease line and private LAN services to give customers to meet their desire for this quality of service. But one of the more innovative solutions that we found has been RFC 7625, authored by Huawei, offering a very innovative solution for providing IP transport and providing that quality of service that enterprise customers demand from the carriers and service providers. So service provider strategies, let's look at Verizon for the Americas market, for example. They've launched a beta program in 2016 for a 4G LTE build-on improvement to their private network. Their national accounts, customers are seeking consistent services through SLAs. So the Verizon is continuing to build and improve their network now to allow customers to have that reliability and that quality of service for the traffic that they specify. So for this reason, I think IP hard pipe is a very good option for Verizon to consider. So IP hard pipes, to meet these challenges of all networks, first and foremost, it offers a very large, high priority end-to-end pipe, which can be expanded, can also be subdivided to meet the customer services required. Secondly, these end-to-end connections, they can be provisioned on a per customer basis. And lastly, these IP hard pipes, they can coexist in the same inter-router links that are also providing best effort and other prioritized traffic services. Well, in the power teleprotection test scenario, we found the Huawei hard pipe transport in our test bed to provide less than 1.5 millisecond of delay between the test protection sensors and the other protection equipment in the power protection environment. The hard pipes were unaffected by other background traffic, even under heavy congested load. That teleprotection traffic was protected and QoS provided. Well, the GSMR railway test scenario with a Huawei router running MPLS and a pseudo-wire emulation edge-to-edge circuit emulation service, PWE3 CES. That scenario, we experienced less than 1.5 milliseconds of delay, and we confirmed that the traffic within the hard pipe was preserved with the background traffic set to lower priority. So very effective transport, considering this is monitoring a simulated train going 300 kilometers per hour. The carrier service provider scenarios, we found the latency for the Ethernet service through a hard pipe. It added only 50 microseconds of delay. And the links, if they failed over, the links would reroute. The Ethernet service would be restored in less than 20 milliseconds. So truly impressive test for the carrier service provider test scenario. Well, overall, our test results confirm the network of Huawei routers with IP hard pipe can deliver unconditional protected service, guaranteed no loss, low latency and jitter in a network. Myricom is very pleased to present the Performance Verified certification for IP hard pipe in accordance with RFC 6725 draft. Congratulations.